Hey guys, here's a short video to help you have a bit more preparation for the test coming up. So, if I were you, I would go ahead and try these problems and see how you go, and then watch this video, pause when you need to, as a kind of guide to get you through it. Okay, so on all of these questions, you have a bunch of roots, and the roots are going to help you find out how to factor it. So because we have a root at negative 5, 0, we know that x plus 5 is going to be a factor. Let's skip the fractional one for a second, and then we have x minus 2 and then x minus 3. So we have these roots, and then we're going to have one other root, and it's going to have to do with this. But the way we're going to find this is we're going to divide this polynomial by each of those factors. So if we divide by the factor x plus 5, when we do the synthetic division, we're going to do a negative 5, and then we're just going to write down all the coefficients, 2, 1, negative 38, 41, and 30. And we're just multiplying those and adding, and now we multiply, and now we add. That's going to give us 7. That's going to give us 6, negative 30, and 0. Okay, so x plus 5, we have divided out. We've got that polynomial. Now we're going to divide that further by this one, x minus 2. So x minus 2, we're going to flip that sign back to 2. Now, one thing to notice is that this positive 2 is the same thing as this positive 2. So the factor is going to flip, right? Minus 2 and plus 2, those are flipped. But when you do the synthetic division, it's the exact same as the x-intercept. Okay, so bringing that down, we got 4, we got negative 5, negative 10, negative 3, negative 6, and 0. And so we've got that guy done. Last one, x minus 3. So we're going to do a positive 3. We're going to bring that down. That's going to give us 6, 1, 3, and 0. So what's remaining is that 2, 1. Oh, that 2, 1 means 2x plus 1. Now let's go back to that root right here and think about this. The reason why negative 0.5 is a root is because 2 times negative 0.5 is negative 1. Negative 1 plus 1 is 0. So negative 0.5 is a 0. Okay, let's do this one. Now in this one, we have a nice root here, but these other guys are kind of weird. So we can't use those. We don't know what number they are. It's asking for the exact value. So give this one a try, and then start the video again and check your answer. Okay, so let's go through this question. We've got that one factor, so that's negative 7. We just use that exact same number when we do the synthetic division. We've got 1, 7, negative 13, negative 91. We're going to bring that one down. That's 1. Multiply it, negative 7. That gets you 0. Multiply it, that gets you 0. Negative 13. Multiply it, positive 91, and 0. So because this is a root, x plus 7 is a factor, and when we divide it by x plus 7, we have the resulting polynomial x squared plus 0x minus 13. Well, how do you factor x squared minus 13? Whenever you see something with a minus sign in the middle, then that should remind you that it's a difference of squares pattern. Now, difference of squares. Let's do a couple difference of squares just to refresh our memory. We'll go back to this question. Let's work over here. Let's say you have x squared minus 16. That's going to be x minus 4, x plus 4. Let's say you had x squared minus 25 is going to be x minus 5, x plus 5. Well, how do we get from 16 to 4? How do we get from 25 to 5? What we did is we took the square root. The square root of 16 is 4, the square root of 25 is 5. So we're going to do the same thing here. Now, the square root of 13 is not a nice number that we can write normally, so we just leave it the square root of 13. And that now is fully factored form. And what would be a good thing to do is to grab a calculator, hit the square root of 13, and if you hit square root of 13 on a calculator, you're going to end up with 3.6. And negative square roots of 13 is going to be negative 3.6. Okay, all right, flip this page over to the back, and let's try some of these ones. Now on this one, it is a 5th degree polynomial, and we have 2 roots. Now this one right here is very special. That is a double root. So because it's a double root, we can actually use that twice. But still, even if we count this twice and we count this once, we only have 3 roots. This is to the 5th degree. That means 2 of our answers are going to be imaginary. So just stay tuned for that. We're expecting 2 imaginary answers. So let's set up the synthetic division. We've got -3, and we're going to be able to run that twice. So we got 1, 9, 30, 38, -15, -63. That comes down. -3 gives you 6, -18, 12, -36, 2, -6, -21, -3 times -21, +63, and we're good. Okay, now again, this is a double root. It bounces off that point. So because it bounces off, we can take that -3 and run it through this again. We got 1, -3, we got 3, -9, 3, -9, -7, +21, and we're good. So we've used up this root twice. That's all we can take out of the polynomial. And this one right here, we got a 1. So let's run the 1 through it and see what's left. So we do the 1. 1 comes down. 1 times 1 is 1. We got 4. That gives you 7. And that gives you 0. So what that means is this. We took x plus 3. Remember, you flip that sign, +3 twice. Right, we did it once and twice, and that 1 worked, so we're going to do x minus 1. And when I divided it by this, and then this, and then this, what is left over is this 147. That means x squared plus 4x plus 7. Now we're not done factoring because it's a 5th degree polynomial. We need 5 sets of parentheses. So how do you factor x squared plus 4x plus 7? Let's bring that down. Just the x squared plus 4x plus 7. Well, the first thing you try to do is you factor it. And you notice there are not going to be numbers that multiply to be 7 that add up to be 4, so we can give up on factoring. We're going to be using the quadratic formula. -b plus or minus the square root of b squared minus 4ac over 2a. So that's our quadratic formula. Let's start plugging things in. -4 plus or minus the square root of 4 squared minus 4ac over 2a. Cleaning that up is going to give us -4 plus or minus 16 minus 28 over 2. Let's bring that over here. -4 plus or minus the square root of -12 over 2. And now we got to think about this. Whenever you have a negative under a square root sign, that is going to pop out the letter I. And so that negative right there, it pops out the letter I. Okay, we can still simplify this a bit more. Square root of 12, well, what is 12? 12 is the same thing as 2 times 2 times 3. So let's simplify that square root. We got a group of 2, so one of those is going to pop out. And that's going to give us -4 plus 2i square roots of 3. Again, 2 things under a square root, one of them comes out, all over 2. But we can simplify that even more, and that's going to simplify to -2 plus or minus I square roots of 3. We're dividing a 2 out of both of those terms on the top. So this is how you factor it. Now, how does that factoring help you know how to, or how does that solution help you know how to factor it? So again, our equation was x squared plus 4x plus 7. When we set this equal to 0, there were 2 values that made 0. So when we factor it, it's going to be x minus. It's always x minus. And then one of the factors is -2 plus I square roots of 3. That's one of the zeros. The other zero is -2 minus I square roots of 3. And so this is how you would factor that. Let's go back up to the original question. So underneath, it's x plus 3 squared, x minus 1, x minus -2 plus I square roots of 3, and x minus negative 2 plus I, minus I square roots of 3. So this one is kind of a chunky question. So just remember, you do synthetic division with this guy again, with this guy, and then when you come down to this, it's quadratic formula time. Okay, let's go do one last question here. Okay, so for this one, we have a nice happy root right here at -3 and a nice happy one at 1, and we've got some crazy decimals. So let's go ahead and run this synthetic division here. We're going to run through -3, and remember you keep that sign exactly the same. So we got 1, -5, -18, 19, and 3. So that comes down, -3, -8, 24, 6, -18, 1, -3, and 0. So we've taken the -3 out of it. Let's take the 1 out of it. So bring that down 1, 1, -7, -7, -1, -1, 0. So what happens is if we take out an x plus 3, remember to flip the signs, we take out an x minus 1, then what we're left with is x squared minus 7x minus 1. So now we have to factor x squared minus 7x minus 1. And let's go down here and do that. X squared minus 7x minus 1. So if you haven't, pause this video and try to do this with a quadratic formula. Okay, negative b plus or minus the square root of -7 squared minus 4ac all over 2a. That's going to simplify to +7, 49 plus 4 over 2. And this one, fortunately for us, just simplifies to this. You can't simplify that any further. You are done. Well, kind of. Now that tells you how to factor this. So in the factoring, let me just write this up above here. We've got the x plus 3, we've got the x minus 1, but now we're going to write this as x minus, and what was that again? X minus -7 plus the square root of 53 over 2. -7 plus the square root of 53 over 2. And then the other factor is x minus -7 minus the square root of 53 over 2. And that is your final factoring. Okay, that's it. So hopefully you had a chance to try those questions. Again, the process is you use synthetic division for all the roots you can find. And then if you can't find any remaining ones, you have to use the quadratic formula to get yourself across the finish line. Don't be afraid of your answers looking horrible like this. It's just all part of the game. Okay, good luck on this, guys.